Hello everyone, these are your video notes on 11.6 ELR. You hopefully completed the anti-set when you came into class today. I do want to go over this just to make sure everyone got the correct answer. We want to put the volume of the three figures from least to greatest here. So we're looking at our formula paper that we have in our notebooks to figure out the volume of a cone first, which is the 1/3 pi r squared times h. Volume of a rectangular prism, the area of the base times the height, and the volume for a pyramid, 1/3 area of the base times the height. So the volume of the cone, when I plug in the radius and the height, I get the volume to be 234.57. When I do the volume of the rectangular prism, I get it to be 120. And when I do the volume of the square pyramid, I get that to be, for the pyramid is 1/3 times the area of the base times the height, comes out to 256. And we're ordering the volumes from least to greatest. So this is first, second, and then the square pyramid is last. All right, so for our video notes today, this is ELR 11.6. This is our last of the formulas from chapter 11. So we're finding the surface area and also the volume of a sphere. You will be completing a paper today on all the ELRs we've covered so far. If you don't finish it during class, you need to finish it for homework. This will be handed in. Don't forget that we have our test on the 12th, 13th, and you should be working on your portfolio. All right, so here is a picture of a sphere. This should be pretty simple to put in your notes. Locating all these things, the center. Here it is, the radius, and then the diameter is the whole thing. Does anyone know what a great circle is called? And hemisphere is half as a sphere. Here is what a great circle is from the textbook. It's when a plane and a sphere intersect in more than one point. If the center of the circle is the center of the sphere, it is called the great circle. All right, so let's hypothetically say we have this baseball shown here. I take it apart, pretty much make it like a net for a sphere. What do you think this total surface area of this baseball, the sphere, would be? Pause the video, see if you can think about it, take a guess. So you kind of have about 4 circles here for this sphere. So we know the area of a circle is pi r squared. We have 4 of them. So the surface area for a sphere is 4 pi r squared. All right, here for our first example, we have the Earth's equator is 24,902 miles long. What is the approximate surface area of Earth rounded to the nearest 1,000 square miles? So we're just plugging in the information that we have using our calculator. And pretty big, this surface area of the Earth, 7,792,527,105 miles squared. Okay, we're moving on to our last part of this ELR, which is finding the volume of a sphere. How do you think the volume of a sphere is compared to the volume of a cylinder? If I was to, as best as I can, make a sphere inside this cylinder, it has the same radius, it has the same height. How many of these spheres do you think are going to fit inside this cylinder? All right, so you're not going to be able to open this link on the video, but if you have my PowerPoint, I'll go into Google Classroom and open the actual Google Slides for 11.6. So definitely pause this video, open up those Google Slides. You will be able to watch this YouTube video, which shows about how a sphere is compared to the volume of a cylinder. So pause the video, go ahead, open up the slides, and then you'll be able to click on this link to view it. So when you watch the video, she pushed down the sphere into the cylinder water by displacement, filled what came out, and noticed that 4/3 of it fills the sphere. So the volume of the sphere is 4/3 pi r cubed. Okay, here's one of many examples that we'll do that you should have in your notes. The first example is one of these snow globes. We need to figure out how much of the water needs to fill this specific snow globe when the radius is 4. So we're using our volume formula, plugging in 4 for the radius. Remember, the radius is cubed here. We work it out, and we get 268.1 centimeters cubed as the volume of the snow globe. All right, here's our second question, example. The volume of a sphere is 5,000 meters cubed. What is its surface area to the nearest square meter? So here we need to go backwards from the volume. So let's write down the volume formula. All right, here we need to solve for r. So we're going to divide by pi first. We get that to be about this, 1,591.55. Now we need to divide by 4/3 on both sides. And we get it to be that amount. Now how do we get rid of something raised to the 3rd power? When it was raised to the 2nd, we would square root both sides. Here, instead, we're going to cube root both sides. In the calculator, if you press the math button, you will see number 4 on the calculator, the cube root button. So go ahead, try it on the calculator. Pause the video if you need to. When you plug that in, you'll get the r to be 10.6. That's the radius. Now we're going to take that to find now the surface area, which is 4 times pi times radius squared. We plug in the 10.6 for the radius, and we work it out. When we work it out, we get it to be about 1,412 meters squared to the nearest square meter. Okay, here's our third and last example for this ELR. Here we have an ice cream vendor presses a sphere of yogurt into a cone. If the yogurt melts into the cone, will the cone overflow? All right, so we need to find the volume of the cone. We need to find the volume of that sphere and see if the sphere volume is smaller than the cone volume. All right, so when I plug in the radius of 4, the height of 12 for the cone, I work it out. I get in the calculator the volume of the cone as 201.1 centimeters cubed. All right, now we need to find the volume of the sphere. All right, when we plug in the radius, we get the volume of the sphere to be about 268.1 centimeters cubed. So this volume for the sphere is definitely a whole lot greater than that one. So that means, yes, the cone will overflow. Okay, so that's it for your 11.6 notes. You could take a look at the actual notes. You have that PowerPoint to look at there. What's on the agenda for the rest of the period, picking up this block day work that you get from the teacher there. It's very similar to questions that you'll see on the Chapter 11 test. The answer key should be on the front board, and it's also on Google Classroom. If you don't finish it in the allotted time during class, then you need to finish it for homework. It will be collected, but then handed back to you before the actual test. If you get this done, you have the option to work on your portfolio. I'll see everybody next time during next class.